Okay, so we're going to start out with your constant functions, okay? So, what does f of x mean? It's y. So this makes y equals c, some number. So it could be 3, -2, 0, okay? And what does y equals -2 look like? A horizontal line that crosses the y-axis at that constant, okay? So that constant really could be any number, okay? Just for this example, we're going to make it -2, so you should go ahead and draw that in. And it doesn't matter what point is on the line, okay? But when x is -2, y is going to be what? When x is -2, y is -2. When x is -1, y is, and when x is 0, y is, and it doesn't matter. You can continue on like this, but no matter what x is, y will end up being whatever the constant is. Now again, it's -2 just because this is the constant that we're using to draw this picture, but it could be any number, okay? Linear functions. F of x equals x, so y equals x. You've actually grabbed this many times, maybe in Algebra 1, but y equals x is your old school classic line that has a positive slope. When x is -2, y is going to be what? -2. When x is -1, y is going to be -1. When x is 0, y is, and when x is 1, y is, and when x is 2, y is, and so you plot these points, and it is your old school classic line, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. If I plugged in 3 for x, what would y be? 3. And it continues on like that. So we're going to draw a nice line, because we want our pictures to look really nice, because these are our notes, and this is what we're using for all of our parent functions. Now look at these two graphs. Think about, like, what is the domain of that constant function? Don't say it out loud, but look at the graph. Think about what domain is. What's the domain of that constant function? Think about it. Look at that linear function. What do you think the domain is for your linear function? What about the range? Okay? I'm not asking you for the answer just yet, but I want you to think about it. Okay? Because we will answer that in just a second. You can use your parent graph to determine this information, okay? You can use these graphs to figure this out. So, for constant functions, we're going to identify the domain, the range, the y-intercept, and the x-intercept. Actually, for both of them, we're going to do that. So somewhere, you decide where you're going to fill in this information. Okay?
You need to make more room after this?
No, we'll be done with linear and constant after this. Looking at that diagram that you have, who thinks they know what the domain is of the constant function? Yes, it is. It's -infinity to infinity. Remember, domain relates to what axis? X and range? The y's. Okay, there was no point on that horizontal line that was not defined. Okay, so that's why our domain is from -infinity to +infinity. What about our range, though? Henry? It's just -2. For our example, if it was f of x equals 3, the range would be what? 3. It's whatever the constant is. That is our range, okay? So the range is going to be c, just that number, or in our example, -2. And you can't write it in an interval, it's just that one number. Do I have any x-intercepts for my constant function? No, I don't. Even if my constant function was the x-axis, was y equals 0, I wouldn't have a specific x-intercept. I would have several, infinitely many. What about y-intercept? 0, comma, -2. Because think about it, it's crossing the y-axis at that constant value. In our case, it's -2. So in general, it'll be 0, comma, c. All x-intercepts and all y-intercepts are written as points, okay? So just remember that. All x-intercepts and y-intercepts are written as points. Just remember that. Linear function. Look at your graph. The line we just drew. Raise your hand if you think you know what the domain is. 2 people? 4, 5, 6, 7. Come on now. Look at that graph. Think about what domain. Negative infinity to infinity. Very good. What about the range? Range relates to your y's. Marshall. It's the exact same. There are no holes, there are no gaps at any point of the y on the y-axis. What about an x-intercept? Where does that graph cross the x-axis? Steven? The origin, which is known as what point? 0, 0. Very good. So remember, all x and y-intercepts are written as points. What about the y-intercept? So it's 0, 0. And there's our information for our constant linear parent functions. Now, when we get to transformations, some of these things may change. It just depends on what types of transformations are performed. Okay? Yep. The next one we're going to talk about is the reciprocal function. Okay? That's f of x equals 1 over x. With your reciprocal functions, if I were to plug in -2 for x, what would y be? 1 over -2, also known as -1/2. If I plugged in a -1, what would I get? -1. If I plugged in 0, it's undefined because you cannot have 0 in the denominator of a fraction. What's happening on the graph when you have 0 in the denominator? A break. What kind of a break? No, it's not a hole. It is an imaginary vertical line called a asymptote. Yes. So it's not going to cross the y-axis. It's undefined there. At no point in time could you plug in 0 and it be defined. So keep that in mind. Okay? When I plug in 1, what do you get? When I plug in 2, what do I get? 1/2. Okay? So if I were to plot this, -2, -1/2, -1, -1, 1, 1, 2, 1/2. I'm not getting too much here on my graph. Okay? So I want to go ahead and do some more points. If I plugged in 3, what do I get? 1/3. If I plug in 4, what do I get? 1/4. If I plug in 5, what do I get? And it continues on and on like that. But my question is, will it ever be 0? No, it's not. So it's getting really, really close to 0, but never crossing it or touching it. So when you draw this, make sure you show that. And it goes on like that, all the way to infinity. And no, it will be 0.0 like 1, but it will never be 0. What if I plugged in? What if I plugged in 1/2? What's 1 divided by 1/2? One divided by 1/2 is? No, not 1/2. 4. Not 4. It's 2. Think about it. 1 divided by 1/2. Keep, change, flip. All students. It's 2. So if I plug in 1/2 for x, y is 2. What would I get if I plugged in 1/3? 3. If I plugged in 1/4? And it continues like that. But it will never be 0 because there's an asymptote there. And the same thing applies to the other side. If I plug in -3, that's -1/3. -4, that's -1/4. -1/2, that's -2, so on and so forth. So you actually have two asymptotes here with your reciprocal functions. Has everyone got it? Make sure they're good. Good looking pictures. These are your notes. Let's look at the information relating to it. Who thinks they know what the domain is for this function? Henry? Just one? Two? Maybe a three. Henry, what do you think?
Negative infinity to 0, union 0, 2.
Because you're saying there's a break at 0. Wasn't there a break? It was that vertical asymptote that was along your x-axis. What about the range? Think about, look at that picture. Is it defined for every y value? Everything except 0. So how would I represent everything but 0? Same way. Okay, use that parent function to answer some of these questions, okay? X-intercepts. Huh? None. Because it doesn't cross it, okay? It doesn't cross. That curve is nowhere near 0, 0. Or the x-axis, let alone. What about y-intercepts? Same reason. They're asymptotes there. What kind of symmetry do we have? Who said that? Origin symmetry. Which means that this is what type of a function? Even odd or neither? Odd. Remember, odd functions have origin symmetry. That's an ODD. Asymptotes, you have two. You have x equals 0, which represents your y-axis, and y equals 0, which represents your x-axis. Okay? X equals 0, x equals is a vertical line, y equals is a horizontal line. Okay? Lastly, intervals. Intervals, I'm talking about where am I increasing or decreasing? Look at that graph, reading from left to right. What's happening from left to right? Decreasing. From where to where? Negative infinity to. Careful. Negative infinity to 0. Because remember, there's a break there. And then from 0 to infinity, what am I doing? I'm still decreasing. Reading from left to right. Okay? I'm going down. I'm going down. That's how I form that reciprocal function. Questions on reciprocal function? Last one that we'll do for today is absolute value function. You guys can go ahead and fill in this chart. Okay? You guys can go ahead and fill in this chart and graph it. When I plug in -2, what do I get?
2.
-1. What? 0. 1. 2.
2.
If I plugged in a +3, what would I get? And I plugged in a -3, I get? And it continues on that way. So yes, this should make a nice V shape. Remember, you should be concentrating on how nice these graphs are because these are your notes, okay? And you already know what types of information I'm going to ask you. Off gate, I'm going to ask you what is the domain and what is the range. I'm also going to ask you about your intercepts, your intervals, and your symmetry. I want you to fill those in, okay? I want you to fill those in. Who thinks they have the domain? That's 1, 2, 3, 4, 5. Zach, what you got? Negative infinity to infinity. Are there any breaks in that V? No, there are no breaks. range. Jamie,
I said 0 to
0 to infinity. Was that 0 included? Yes, it was. So I need a bracket. Yes, think about it. Look at the graph. It's only defined for 0 in all of my positive numbers. Because remember, absolute value means anything positive. So my y's, no matter what, are going to be positive. What about my intercepts? Who thinks they have those? Intercepts. Intercepts. 3 people? 4? You more? Sierra, what you think? Okay, now remember, intercepts are written as points, so that would be the point 0, 0. And that is your x and y intercepts. Both of those are 0, 0. Is it decreasing anywhere?
Yes.
Yes. From where, Tiffany? Where's it decreasing? From negative infinity to 0 is decreasing. And what's happening from 0 to infinity? It's increasing. Think about it. Reading from left to right. I go down and I turn up, and that's how I make the V. Turn up. There we go. And the last bit, symmetry. Is there any? The y-axis is symmetric about the y-axis, which means it is even. It is an even function. Absolute values are even functions, apparently.